So I want to continue the messaging about the upcoming flows feature, which we're due for the end of the quarter to come out for the next thin-edge version. So I wanted to, again, do a bit of like a refresher. What is it? So I've been trying to do a lot of the public demos to just explain what it is, how will you benefit from it, just to kind of educate people before the feature is there, so people can kind of, hit the ground running when the feature is then officially released. So it is a little bit, there's a few slides because I just want to contextualize everything and then show some really fancy stuff, which is looking at the Sparkplug B, like how do you integrate devices with Velocity that's talk a Sparkplug B MQTT protocol. So bear with me. If you have any questions throughout, just, it's more interactive. So just, raise your hand or speak up. I don't mind being interrupted. Yeah. So just in case, if you haven't heard us talking about flows already in probably the last 3 public demos, I believe. So the flows, you can kind of think of like data flows. So you want to be able to take some input, which is maybe on your local MQTT bus, do some transformation, some filtering, some aggregation, and then produce another message on the output. So this has many, many applications, and the team has been very, very hard at work for quite a long time to make this an awesome feature. So I'm just the person that gets to present all these awesome features. Obviously, the whole thin-edge team, and particularly Didier, is like leading this feature. So there's been a lot of work to invest to get this all functional. So again, the advantage of using thin-edge is you have a whole team behind it, developing it and continuously developing it. So the flows in the context of thin-edge, so like we had before, we've always had thin-edge installed on, let's say, your gateway or a device or VM, doesn't matter, anything kind of like a Linux box. And it's always been kind of like the interfacing with some local apps on the left side, doing some magic on the MQTT level, and then communicating with the cloud or clouds using a combination of MQTT and HTTP, but primarily MQTT. So we do a lot of device management and all that kind of stuff. So that's the status quo. But we kind of heard a lot of people going, well, actually, I want to do more. I want to maybe do my own custom mapper, or do some local analytics and stuff like that. And we found a lot of people having to write their own application, which is a lot of overhead. So, you have to write your systemd services, do packaging, do architecture-specific builds, having dependencies. It becomes very, very complex very quickly. And then that can detract from this usefulness of a plugin kind of ecosystem, because the more specific you have to be with like the runtime environment, the harder it is to get it out to your customers. Because you might have only gone, I think only anyone's using ARM64. That is not the case. So then you have to build then for x86, 64, and all of these kind of additional variants, which you can quickly get into a problem delivering all of this stuff for the people that you want to kind of use it. So with the flows, it kind of abstracts all of that for you, because in the end, you just concentrate on the message processing. You don't need to worry about MQTT connections, nothing. We do that all for you. So there's really focusing on that kind of business logic that you want to put in to do whatever, like aggregation, filtering, message mapping, whatever. And you can run that all in the convenience without having to worry about systemd services, for instance. So there's a whole host of reasons, but I'd much rather kind of get into the nitty-gritty details shortly. So with the flow, it takes an input at a fundamental kind of level. Something comes in. Let's be a little bit, vague with what that something is. It's just composed from multiple steps. So the steps each execute like some kind of either built-in function or like a JavaScript function, which gets executed and it goes to the next step. So it means you could just have one step in your flow, totally fine. Or you can have multiple steps, also fine. But in the end, you have something coming in, doing some processing, and then you have some output. That's it. At the fundamental, that is all a flow is. So it's not too complex. And all of those steps. So we have a JavaScript engine, so built for embedded systems, I must highlight. So we're not talking about Node.js. So we're talking about really embedded devices. I think the JavaScript engine is about 1 megabyte in size, which in comparison to Node.js, I don't know what they're up to now, like 40, 70 megs or something like that, which is just is at odds with our, hey, let's run with a low footprint. But also it comes with a lot of sandboxing. So you don't have access to the file system. So we try to make a safe space for you to run these kind of JavaScript code without kind of exposing everything to have like security concerns about you giving access to, you know, some file systems that you don't want people to have access to. So you have a bit of like isolation and yeah, like sandboxing there. But the important thing also is, so this flows concept, this is actually common to all mappers now. So whether you're running like Comlosity mapper, you can kind of put flows in that. AWS mapper, put flows in that. Or if you're going, well, actually, this kind of mapping flow logic is actually not related to the cloud, you want to do some local aggregation or statistics or whatever, then you can run a new mapper called TedgeMapper Local. So that doesn't need a connection to the cloud. That just runs like on the local MQTT bus, takes messages in, puts messages out at a, you know, fundamental or like a rudimentary kind of explanation. Harold, yes.
So can you also chain multiple of these mappers together to have more complex flows where you want to do maybe some pre-processing that's common for multiple steps later?
So kind of. So not in a flow sense, but in a flow, you can dictate what the input is. So you could chain that and do your own kind of like input-output chaining back onto the MQTT message bus, and then feed it back into another flow, absolutely. From a chaining level, because the moment you start doing more complex things that you have like interactions in between different flows, the harder it is to track. So whilst we would probably kind of recommend from kind of our own experience, if you can do it, put it in a single flow. You can have multiple steps to segregate some of that logic. So you could have like a debounce message, which just, you know, delays the output of something and then batches things together. So, you know, you could put that as a step 2 kind of thing, or a filtering step 3. So the more you have in a single flow, the easier it is to kind of debug. The moment you have like interactions in between different flows that you have doing something going in, going back to the message bus, going to flow 2, go back in the message bus, go to flow 3, it becomes a little bit harder to track. You can definitely use it like that, like, because that's the great idea of this kind of flow concept, is that it's very simple. So you can kind of compose it however you want. You could also reuse steps across flows if you really want to, because in the end, the flow is just linking to a JavaScript file. You could have a common set of those JavaScript files as well to reuse code from that level. But again, the moment you kind of start reusing code and you kind of break this dependency in between the flows, and the question is, what happens if you update that? Can you update that independently of this common code or not? Are you guaranteed that it works? And then I think the answer will be no. And then you can get into some tricky situations that way. But it's very flexible, so you can chain it to whatever you want, but that'd be up to you.
Okay. But say, for example, I want to modify all measurements going to Cumulosity to contain an additional fragment. Then yes, I would create or modify the flow specific for the Cumulosity mapper to include basically an additional step.
Yeah, spot on. I couldn't have described it any better. That's exactly what you do. So you would have like, you know, add in step 3, and then that's it. Yeah.
Okay, that makes sense. Thank you.
And Christoph.
I have a question on when you invoke a flow from input to output, and that triggers something in another flow. Is there some means to debug or to follow up what happened?
Not from the input to the output. So the debugging from one flow to another. So everything here from input to output is one flow.
Okay. Mm-hmm.
That we have ways to debug it. So we have a test command. We're still working on a few tweaks to get it working full end-to-end with all the mappers and the built-in functions. But that will be included in the release, definitely. But yeah, so it should be easy to debug that whole sequence. But if you have two interactions, then they'll be up to you to kind of like trace that message. But again, it's all about testing is about isolation. Like, what's the minimum input-output function I can define? And you can write your just tests and everything like that to test it all offline without even having thin edge. So if you're just using JavaScript things, there's nothing magical we're doing. So you can just use the existing JavaScript tooling, so Jest or whatever your preferred unit test framework is to achieve your testing even before it then lands on the device.
Okay, thank you very much.
Okay, so this is just kind of highlighting like deploying flows. So each different mapper basically has its own kind of folder structure, so you can put the flows in there. So with Tedge mappers, so for example, the Convelocity flows, you'll see everything located there, and you can put your own kind of stuff in or modify, etc. Really up to you. And with the building blocks with the flows, you know, the flow is the definition that says, what am I? What's my input? What's my output? What do I process? So you basically set a connector. So we have like a few simple ones. So those people asking for like, I don't know, Pulsar, whatever. No, not at this point in time. And you have to remember we're kind of like on an embedded device. But we have fundamental inputs that you could probably chain something quite easily. So we just have MQTT topics that we can subscribe to, file input, and also process output. So you can see that you could, with the process output, that's quite powerful, that you could also chain that to whatever CLI thing that you wanted, which may be even a Pulsar client to then feed stuff out onto the standard out. So we're hoping that these fundamental bits are there that people can also extend themselves to extra connectors or whatever. And then we're always interested in, you know, how do we improve this and make it more useful to more people that we can extend it in the future. So we're more focusing on the core kind of functionality at the beginning, and then we can kind of like evolve it over time. And the steps, as mentioned before, and then also the context, so that each of the like the steps being executed, they also have access to an additional context. So that's a little bit, so you can use to share state in between different steps within flows as well, like across flows, also within the mapper. It's probably a bit more of an advanced topic, which I won't go into today, but I would encourage reading our documentation that we have about this. But that'll be part of like all this kind of educational aspect. And then quickly, because I want to get into the fun stuff, the demo. So there's an example of a flow definition that we have some kind of inputs. They're saying, I want to take every input message from this MQTT topic. So here we're processing measurements on the Tedge topic. Maybe I want to add a timestamp. So this is using some of the Rust code that we have to, you know, add a RFC 33339 timestamp to it. Do some kind of custom whatever thing you want to do to it. And also then apply some kind of limiting the payload size, because this is what we're doing already. Because if you exceed the payload size, you will get kicked off by Commvault or like by the cloud you're talking to if you exceed it. This is applicable pretty much for any cloud. So being able to kind of limit the message size from the output. So it's kind of like a filter function. So we'll drop messages if you exceed that thing and then create an alarm for it or like an error message. Okay, so I'll jump over a little bit of the smart functions. So we have like the JavaScript, fancy word for it. So the on message handlers. And so in ThinEdge side, we have a few more because we have a few additional kind of use cases that on the device you want to maybe do aggregation. So we have a few like special like on interval to facilitate aggregation like use cases. So you can basically collect messages and then execute something periodically. But the on message is basically just taking in that input message, whether it's from MQTT, from a file, from a process, whatever, then doing something and then producing a message on the output. Simple. So you can publish it back onto the MQTT broker. You can publish it, like write it to file if you want. So we coordinate all of that for you, and you can basically do anything and you're, as long as it's like ECMAScript 2020, then you're good. You can also transpile from TypeScript down to ECMAScript 2020. There's a massive amount of tools that do that for you. We also have a few examples in our examples repo. Okay, so I'm going to jump through the use cases. So bandwidth reduction, yeah, doing some protobuf encoding, things board, which we showed last time. And the thing that I want to show today, which is the cool bit. So maybe you want a protocol bridge. So if you're on the device and you're in the OT kind of space, and going, well, actually, I have a few industrial PCs or PLCs, sorry, that are already publishing in this Sparkplug B format. So Sparkplug B format is like an MQTT protocol. So it's on top of MQTT, publishes some messages in a protobuf, predefined protobuf definition, and then clients can then subscribe to the information to that. And then, so we can actually take that Sparkplug information, which is in protobuf, which is a binary format, decode that, then change that into the thin edge format, for example. You could do the opposite way as well, fine. But here I just want to kind of focus on, you have a PLC which is already producing this data. So there's a few kind of like PLCs out there that do that. Like I think the Ignition, there's some software there which can interface and play that kind of bridge for you to produce those messages and then translate them into the cloud. So that is possible just with our JavaScript stuff. So I think in all it's about 160 kilobytes, but that's CPU agnostic and it's quite full featured. So I wanted to present going, with these simple concepts, we can actually build something really complex and to fulfill a very complex goal. So that's kind of what I want to highlight. And edge analytics, you'll hear about a lot of this stuff then on Friday. So let's look at parameterization. So just looking at time. Okay, so before, just a bit of like a demo, like before we get into the demo, you kind of need to know a little bit about Sparkplug. So Sparkplug B, I think there was a Sparkplug spec and then there was Sparkplug B spec, which is like just a refined version of that. So if you're talking about Sparkplug B, maybe out of curiosity, like put an emoji or something if you've heard about Sparkplug B at all, out of curiosity. Okay, so a few people. Okay, and also a few people that haven't. So it's basically meant to be like a bridging concept of, how can we make this kind of OT space a little bit more palatable for the IT? At least is my interpretation of it. So trying to do a generic kind of protocol exchange, which is mostly geared up for PLCs, doesn't have to be, to then basically take those messages and do something with them. So there's predefined topics. So for example, everything starts with this prefix, but it has also this kind of like gateway style. So you can do like, I think they call it a node, which I think is for us a gateway in our context. And then you can kind of, different devices can publish to it. And then you have something sitting on the MQTT broker, intercepting those messages and going, okay, I know what this is, and then publishing them. So this is a little bit of like, you get a bit of state awareness, whether something's online or offline through retain messages. So if we go into a bit of details, so we have at the fundamental core, we have like birth and death messages. So the birth messages, when something which publishes Sparkplug messages comes online, it'll publish like this birth message that says, hey, this is me. This is what I can do. This is how you address me. That's it. So it includes like the full set of metrics or like telemetry data. I think they call it metrics. Metrics that they have, including like the full key names of those metrics. When that client goes offline, it sends a death message. So usually through the last will and testnet of the MQT. And then during the normal life cycle, so we'll have, sensor data, which is being updated. So that's denoted by this data, or like, I think it's the D data because that's device data, and I think that's node data. So it generally comes from the data topics, one of them, and that will be basically publishing the new values of the sensors. and then it can interact with a few commands. But the magic really comes on the data messages. So when it publishes them, because you can think one of the primary goals, or like one of the additional goals, is also reduce the bandwidth usage. So especially if this is going to the cloud or something like that. So they brought in an alias topic, or like an alias concept, that all of the data messages coming through, they're going, actually, we don't need to repeat ourselves what the actual metric names are, because we've actually included them in the birth message. So they can actually reference the metric keys. So that long string, that, temperature sensor, 1 or whatever, they can actually shorten that to a digit, or like an integer. So they have that concept that you can do this. But because of this kind of aliasing concept, which is where you save your bandwidth, because you're significantly reducing your bandwidth of the messages while still being very descriptive with them, it means that the client on the other end is stateful, because it needs to combine the messages it's receiving from the birth message to going, that's my key alias thing. So just keep in mind, that's where the complexity comes in. So we're not talking about a simple message translator. There's a bit of brains to it. And part of that is also being able to react from messages, because you might have missed the birth message. So there's also a protocol to basically ask for a rebirth message, and that's sent through the command kind of topics. Okay, that's enough. Now let's get into the fun stuff. Okay, so for this setup, so I'm actually running this on my Mac at the moment. So just for convenience, I didn't want to fire up something else. So I have my device here. I can actually check what flows I have deployed on my device. And I can see here, this is the magic one that I want to focus on today. So the Sparkplug telemetry. So it's taking local messages, which are in Sparkplug format, so protobuf messages, and converting that to thin edge messages, which then get propagated to the cloud. You can see I have some other flows installed. So actually see that these are the built-in ones. So from the Comvelocity, so the Comvelocity mapper also has some flows which are exposed, so you can kind of like customize them if you want. But here I'm actually using the local mapper because it's kind of agnostic. It's just doing local processing, so I kind of want the life cycle of this flow to be decoupled from what Comvelocity is doing, like the Comvelocity mapper. So I'm a little bit flexible with my deployment. So with that, how does it look? So if we go to the child devices, we'll see we have this kind of simulated CNC machine. And if we go down here, and so we have the name of it, CNC machine, it has identity as normal. And let's have a look at the measurements. Cool. So all of these measurements, so this is for the last hour, are coming via the Sparkplug B. So this is more like, this is the end result. We'll show how the magic happens. But we can see here that we have a combination of measurement data coming in. We have alarms, which is also being propagated over the Sparkplug B protocol, and also events. So I can actually check out the events. You can go here, we have like a door open, and I think there's like an e-stop, which will be triggered at some time. It's a random simulator, so it will come up at random times. But this kind of the new data explorer view is quite useful for showing all this kind of useful information on the spot on one page. And then I can see, for instance, I have some hydraulic pressure kind of alarms, which have been raised and cleared now. So I can see it all here, and then see that, when the pressure gets above 157 bar, then it will trigger an alarm. So that's all stuff coming from the Sparkplug B, kind of like the device publishing those messages. So that's showing everything's working. Like, okay, how does that work? So we thought you're going to have to probably help me out a little bit for sizing, because it's a little bit of like a lot of things on the screen at the moment. How's that for a font size? Ignore what's the right side, just this left side. Is that fine? Yeah, cool, thanks. So I figured writing, so I decided this was a good exercise for at the beginning of this, I didn't actually know too much about Sparkplug B. I've heard about it. I generally know the concept, but I didn't really know what it meant in terms of it's stateful. How does it, get its message compression and all those kinds of things? Because it can't just magically be less payload. And that click about the alias was the one that really kind of made sense to me. So for this, I heavily lent on AI to help me out learn what Sparkplug B is. And when writing a flow, I was like, well, I kind of need some Sparkplug B messages to even test this thing. So I asked to create a simulator that publishes Sparkplug B messages. So my kind of personal language of choice is Go. So on the left side here, we just have the terminal user interface, which is generating simulated CNC machine data on Sparkplug B. So it's publishing on the local broker. And then here's just the fancy rendering of what it's doing. So we can see the pressure of the hydraulics, speed, etc., and then also any IO that changes. Then here we have a bit of an event log, which is like different because it's going through kind of like simulated programs. And then we can see if there was any kind of alarm raised, we'd also see this in its list. So at the moment, this is just kind of publishing stuff for me so I can see what's kind of going on. Now, the first problem you run into is going, well, Sparkplug B messages are protobuf. If you know anything about protobuf, these are binary messages. That is a little bit difficult to debug, right? Because if we have a look at this, and I know this is going really techy, but I think it's good to highlight the issue. So we can see here that is the birth message, because that's retained, so that's usually coming in pretty quick. That this is actually not UTF-8 because it's binary. So we, a while ago, added support that the TEDge MQTT sub, when it detects non-UTF-8 kind of payloads, we base64 encode it. So it's printable on the console, otherwise you get like random weird characters that you can't really do anything with. But at least so we automatically convert it to base64. But as you can see, this is kind of meaningless to a human. This is more for machines. And if I go, print to base64, decode, okay, I can read a bit of information from it, but there's a lot of like substituted characters because it's not renderable on the console. So I was like, okay, that's a bit difficult for me to work with. How do I work with it? Again, another good case for AI going, well, I have no interest in doing this myself. And it would take me a while to do. And the good thing is the Sparkplug B protocol is very well defined. So I also asked, can you create a decoder for me? So I can just see the messages, because this was a bit of like a educational thing for me personally, because I didn't really know how everything was running. So if I just pause the simulator, because I have a whole bunch of messages being actually generated. No, one sec, let me just unpause that for a sec. Okay, so we can see here that this is just a tool to render it. So we're still not on the flow yet. This is just more for understanding what's happening before we even get into the mapping. But we can see here that, let's do a rebirth as well. Pause that so it doesn't get too many messages. So we can see that this data coming in from the node is actually containing all of the information about the metrics from that device. You'll notice here that I just called alias. That is meaningless for me. So, but this is part of the protocol. So because you have the retained messages, which have already been received by that this specific client, that has the mapping of the aliases. Like, so they're just numbered from 1 to X or to N. So in this example, I didn't know the context, like what was the aliases here. So I sent a rebirth message. So I sent it back to the thing publishing the Sparkplug B messages and said, hey, I missed that birth message. Can you resend it? So it's a rebirth message. So I sent that here in the control. So there's like a rebirth message here. And then it responded going, right, okay, you probably missed my alias mapping. Here it is again. So it resends the birth message. And then here you'll see that it includes now the full names of it. So no longer the alias for it. So not like 1 to 23. It will include the full key to it. So now the client takes that list. And then, so the next time you can see here, the next time it published, so that includes the keys. So I know what my metrics mean. Then subsequent ones go back to using the alias again, because, you want to save kind of bandwidth. And so that has then using the aliases again, but then you know what kind of, how to interpret those kind of metrics, and you go, okay, I have the birth message, which has my, lookup table, and then I can convert these to my meaningful kind of representation. Because when we're publishing to Velocity, we need that kind of like the actual names, but they're not coming on every message. Now you see there's a few other messages. So this is where we start peeling in the flows. So our flow does all this. It is a fully compatible Sparkplug B client. So it knows about the protocol. Again, generated by AI, because I didn't want to do this myself. And I didn't know how to do it at the beginning. So that was the key. So we see that the output of this, so in the background, I have a local mapper running. So this is already, I have my flow deployed there, which is a bit of JavaScript, about 160 kilobytes in size, because it's doing a protobuf decoding and everything. And it's taken that message and went, I want to convert that to the finished format. And that's what this message that we see here. So it's already converted that to the thin-edge message. So it's converted, so it's listened to those birth messages, taken those list of things, put that in memory somewhere, waiting for those data messages from Sparkplug B, using the lookup there, disseminating the metrics, pulling out the units from those metrics, publishing the units in the new, so we added that about, I think 4 months ago or like 6 months ago, the ability to publish the units for different measurements on the TEDge interface. It's publishing that. And so when it publishes the TEDge measurement message, which is the exact values that I cut in here, somewhere, yeah, this one, for example, like spindle speed, and it's kind of grouped them as well. And that's all it has to do. And then the normal kind of mechanism for the built-in velocity mapper, which then converts from that generic thin edge format into then the velocity format. So the important thing here is the flow output I chose was the TEDge format. And the reason for that is so it can be generic. So if you have an Azure mapper or a Thingsboard mapper or whatever, you can take in the TEDge format and then do your appropriate translations. Because that's the whole point of trying to build something locally on your embedded device that can be generic so that you can then publish it out into different kind of clouds, which is fine. So we can see this is an example that, so we have the measurements, so the axis and different positions, it has the units, because the mapper, because we previously published the units on the retain topic on the TEDge interface, you can read about in the reference manual, that everything kind of comes together. And so our flow just has to worry about Sparkplug B protocol and output thin edge messages, nothing more. It doesn't need to know about any clouds, doesn't care, which is fantastic. Stefan.
Are you aware of Sparkplug? Because I'm also struggling with the conversation of aliases back to names, and I did not find anything regarding of the name patterns or something. So metrics is just crazy. Yeah, it can be slash dot whatever. So you assumed you introducing dots, and then you can say this is the fragment series kind of stuff.
Yeah, so yes, definitely. I believe part of the spec, there is no mandated naming convention, which I agree, that is a big hole. But the thing is, you can usually, so with units, I mean, you could be doing some smart detection for units, like going, hey, that looks like a measurement or metric series. So you could do some like heuristics on going, does that look, do I detect a pattern here? But yeah, you're right. You probably need to definitely have a fallback mechanism going, well, if it isn't using dot notation, doesn't need to be. You could also flatten the structure. But this is also something which is really key for the whole point of flows is also to add, and I skipped over that page, parameterization. So when you write a flow, the person writing the flow might not know all of the input parameters and control knobs that they want to tweak or define at that time. They might go, well, actually, our users know better. So the flows, you can also define some kind of like externalized parameters that users can define, which could even then say, do I want to do a normalizing function? Like, what are allowed characters? And you could kind of swap out those allowed characters for your preferred character. So that could feed into a regex sub command, which is super easy in JavaScript. So it lends itself really, really well to, you don't have to know all the answers when you're writing the flow. You have to counter for the situation and going, well, the user might know best. I'm going to allow people to, provide a generic replacement input and output kind of function, or like via text. And then that is a very powerful mechanism to allow those things that you might not yet know. But yeah, that's a bit of like a gap, I think, in the protocol, that they're going, well, name the metrics whatever you want.
Yeah. And also there's no unit of measures kind of stuff like you said.
Yeah, exactly. So, but that leaves it very good on the next point for, so what I'm not showing here is the creation of the events and alarms, but that's also happening under the hood. Let me just unpause that, or maybe we'll see a little bit of it. So because of, in the Sparkplug B protocol, if we look at these, let's go back to the birth message, you'll notice that in Sparkplug B protocol, you just have metrics. There is no concept of alarms. There's no concept of events. So the convention to encode that, so I think they do actually mention a convention that you encode it, especially for alarms, you encode it within the metrics. So here, like you have an alarm, something, but also like you have no delimitation. So it's basically a, I think the convention is also to have, so an alarm will have text probably, and also is it active or not? So usually they just have a convention of using the same prefix and then having an active and text. So I think that is kind of listed in the Sparkplug B protocol, or at least in the convention section or whatever, to be able to kind of decode that. But it shows that this kind of interface is quite complex, and we've been able to do everything. Like, so for us, it was a little bit more of a stress test of like flows. How, can we actually solve real world problems just using JavaScript in a sandboxed environment? And the answer was yes. So I was a little bit surprised that we were able to kind of get something so fully fledged. And it's also, it reacts. So it will also send rebirth messages itself. So it shows that this really, really simple interface of input-output messages can actually be used to create very powerful tools. And I'd say this is like an application and not just a data flow kind of thing. It's a full application, which has been made possible, and I don't need to worry about servicing or whatever, or packaging, purely with our flows feature. Yeah, so all of like the code also for these kind of clients are in our examples repository. They haven't been merged into main on our examples repository yet because they're getting a little bit wild. So I think it kind of seems they probably need to go on their own repository. But I found it as a very useful kind of tool to learn a little bit more, and I like seeing real examples of things. But it was really cool to also understand the protocol, seeing the messages, seeing the interaction with how, how does the message get translated from ThinEdge and then the outcoming Comlocity message that gets sent to Comlocity, and all that. Quite a powerful kind of learning tool as well. Especially like even getting the units to work, that was actually quite easy. which is really cool. And it was mostly like all kind of AI driven to saying, hey, I want this, I want to follow the spec. Can you do rebirth messages? So you kind of had to learn a bit of the terminology and stuff like that. But it was a relatively simple exercise to get a quite advanced application in the output. Cool. So I think that was the main stuff that I wanted to show. We'll try to show a few more tidbits also on the community meetup. Mario, you have a question?
Yeah. So can you leverage existing JavaScript libraries, or is the decoder that has been done like done from scratch, or how does it?
Yes. So that is a very good point. Oops. So what does that actually look like? So Sparkplug B. So in our examples repository, because we're trying to build like full examples, which are, you can deploy yourself and then see how to build them, write unit tests and all this kind of things. So we have a repository here where this is the flow definition. So the flow definition is pretty simple because it just has to subscribe to the Sparkplug B topics, because we already know that ahead of time. And then saying, run one step, main.js. So because this is non-trivial, usually typing helps. Otherwise you get in a bit of a mess, especially for like AI, typing definitely helps. So this is actually my Sparkplug B definition. Like flow JavaScript file. So you can see it's quite sizable, but this isn't all the code. So if we go up, it is importing JavaScript libraries. So the protobuf library, I'm importing some kind of like some local type definitions that we currently have, which are only in the repository, but the idea is to kind of eventually publish them. So there you can just kind of do a normal import like this to get our definitions. And I'm pulling in the Sparkplug B JavaScript, which is the output when you kind of have a protobuf definition. You can generate different language classes or like functions. So it's pulling that in. And the build step that we have, so in the end, on the device, it needs to be a full self-contained module. But that's exactly like JavaScript has been doing this since the dawn of time. So there's a lot of tooling can do this. For us, we've had pretty good success with ES build. So part of our examples, so if you look at my package JSON file, our build step is just saying ES build, convert my TypeScript. I'm actually transpiling it to ES 2018. I want to bundle it. So that basically means a fancy way to say, put everything in the same JavaScript file. I want to output the file to lib main.json. I also want to use ESM formatting. I think imports to have like a full ECMAScript module and not like the common JS and stuff like that in the different variants. And that's it. So if we look at the lib, this is where the size comes from, because when you're creating a bundle, which means everything that you need to run that thing is it within one file. So you're not doing imports and stuff because it's going, I see you're importing, and it converts that into one single file and it'll do all the heavy lifting for you. This is done basically in every JavaScript thing, unless if you're running like Node.js on a server. So it will say, you can kind of see where all these kind of descriptions are coming from. So you see that all of like the protobuf stuff, it's pulling in all of that kind of, a lot of things. And then somewhere down, if we just do on message, that is my transpiled JavaScript, TypeScript code into JavaScript, ECMAScript 2018. So it looks a little bit different because it's not TypeScript, and it's doing all that for me. So it's fully compatible. So you can see like it's still sizable, 4,000 lines. But compare that with writing your own application. This is 160 kilobytes. Unless if you're writing something in C, you will not come anywhere near that. And the complexity of doing your own MQT, you need an MQT library so you can, create a client there that subscribes to it. You need to worry about the last will and testament message and all these other things, which is all kind of like burden. And in the end, you have something that you need to compile, which is then architecture specific, CPU architecture specific. Stefan.
You said at the beginning that you store the definition of the names to the alias in the memory. Is it the context you're using for that, or is it something else?
Yes, it's the context that we're using. Yeah.
So you just write a key value stuff there, and then if you receive the messages, the data with aliases, you just read it and then map it accordingly.
Yeah, look at here.
Yeah, okay. Alias map. Okay.
Yeah.
Interesting.
So it means so that context. I think that probably deserves its own demo. But I think the key takeaway there is when you're writing non-trivial things, generally you might have some state. Like the goal is to have something stateless because it's simple.
Yeah.
Right? But obviously that has its limitations. That some things require state, like this one. So being able to put that state somewhere, which is part of the actual kind of runtime scoped part. So, if we were, so currently I don't think we store it to disk, but we could in the future potentially, store that state to disk and going, hey, when you restart the service, we'll pre-populate that with the stuff on disk. So that's all things that we can kind of make available in the future for that. So it kind of lends itself to using those kind of predefined mechanisms. And in our kind of like engine, we also have the ability to define the scope in different kind of, like define the scope of your context. For instance, maybe you have something which is private to your flow, which you don't want, having clashes in between different flows. Because, with naming can be difficult. And if you choose something generic, and if that would share state with another flow, then you could have conflicts. On the flip side, maybe you want to share state. So we have different contexts available for different kind of scopes, which some are available across different flows. So we have like 3, the script, the flow, because you can also have like different instances of the flow. And we also have the ability to, so if you have multiple steps, you can share the same state across the flow. So it's not just the script. So the script is a single step, basically. Or you can have the whole mapper. So if you have like multiple things running, so you can do like complex things like, I don't know, if you wanted to have a message tally, how many messages been sent, and then have some kind of like circuit breaker mechanism to feed into other kind of flows that you can have some way to trigger a signal which is accessible from other flows, from one flow to another. But again, that's probably not that probably a bit difficult to grasp at this point in time. So I think it's better highlighted with examples. But I think we already have a bit of documentation about like the reference documentation, but we also want to build out on the tutorial side to try to do like a step-by-step. Let's start off with the basic, input-output function, which is, I don't know, just changing another topic or something. And then how do we build onto that with sharing state across flows and doing more complex things, aggregation, and all these things. But yeah, that context becomes really, really, really powerful.
Yeah.
Yeah.
It was also key here for Sparkplug B.
Yes. Yeah, it wouldn't be possible without it. Or it would be possible because I think Sparkplug B, I think I have a convention that you can actually say, please disable aliases, but then you lose on the benefit of having smaller messages if you want to kind of reduce bandwidth. Yeah. So we originally did kind of also start out with having a reverse. So publishing thin edge messages or converting thin edge messages to Sparkplug B messages. I'm not sure whether it still works because I focus on the other one first, or like switch to the other one for more demo purposes. But it shows like the powerful, it's the same kind of concept. You could also do the reverse. Like if you want to communicate to that PLC with Sparkplug messages or like another gateway, you can convert a sensor which maybe isn't in Sparkplug format, but publishing in thin edge format. You could then publish that back onto the bus in Sparkplug format. So something else in the network could then get the data about the sensors. So that's a real powerful mechanism of these flows, and that we want to kind of like inspire people to write really cool ones to solve real world problems, and not always just have like a fictitious, oh, let's just convert message 1 to message, message A to message B format. But this is a little bit more pushing the limits and to see if it's possible. Cool. So I hope that, I know it's probably been a bit of like information overload, but I think the video will be available online, so you can kind of, rewatch it and stuff. But I hope everyone's kind of like geared up for the Flows launch that we're hoping to have in the next few weeks, that everyone starts to kind of use it and then can benefit and don't have to write their own Python clients to do simple message translations anymore.